The story of mathematics begins with a simple need to count. Early civilizations in Egypt and Mesopotamia needed ways to keep track of their grain, their livestock, and their taxes. They developed systems of writing numbers and performing basic arithmetic. Imagine needing to count your sheep every day. It would take a long time. These ancient systems were the first steps in a journey that would transform the world. Egyptian mathematics used a system based on 10, just like ours today. They had symbols for 1, 10, 100, and so on. They could add, subtract, multiply, and even do fractions. But their system was cumbersome and calculations could be time-consuming. Meanwhile, in Babylon, mathematicians were developing a system based on 60. This might seem strange today, but it had advantages for astronomy, which was very important to the Babylonians. They could track the movements of stars and planets with remarkable accuracy. We still see echoes of their base 60 system in our measurement of time and angles. These early civilizations may not have had sophisticated tools or formal systems of proof, but their practical needs drove them to develop the foundations of mathematics. Their insights would lay dormant for centuries, waiting for the right minds to build upon them. Around the 6th century BC in ancient Greece, mathematics took a dramatic turn. Greek thinkers weren't content with just calculating things. They wanted to understand the underlying principles. They began to develop a system of logical reasoning that would become the bedrock of mathematics for centuries to come. One of the most famous Greek mathematicians was Pythagoras. He is best known for the Pythagorean theorem, which states that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. This theorem has countless applications in fields like construction, engineering, and physics. Another giant of Greek mathematics was Euclid. He lived in Alexandria, Egypt, around 300 BC and wrote a book called The Elements. This book, organized into 13 volumes, laid out the foundations of geometry in a clear, logical way. Euclid's work was so influential that it became the standard textbook for geometry for over 2,000 years. The Greeks' emphasis on logic and proof transformed mathematics from a collection of practical techniques into a rigorous intellectual discipline. Their ideas spread throughout the ancient world, influencing mathematicians for centuries to come. While Europe was in the midst of the Dark Ages, the Islamic world experienced a golden age of scientific and mathematical discovery. From the 8th to the 13th centuries, scholars from Baghdad to Cordoba made significant contributions to algebra, trigonometry, and astronomy. One of the most important figures of this era was Muhammad ibn Musa al-Khwarizmi, who lived in Baghdad in the 9th century. He wrote a book called The Compendious Book on Calculation, by completion and balancing. This book introduced the concept of algebra to the world. The word algebra actually comes from the Arabic word al-jabr in the title of his book. Islamic mathematicians also made significant advances in trigonometry. They developed tables of sine, cosine, and tangent, which are essential for navigation, astronomy, and surveying. They also developed new techniques for solving equations and working with fractions. The Islamic world played a crucial role in preserving and expanding upon the knowledge of the Greeks and Romans. Their discoveries would eventually make their way back to Europe, sparking a renaissance of mathematical thought. Section 4. Renaissance Revolution, Europe catches up. By the 12th century, Europe began to emerge from the Dark Ages. Scholars rediscovered the works of Greek and Islamic mathematicians, and a new era of mathematical exploration began. The invention of the printing press in the 15th century made it easier to spread mathematical ideas, leading to a rapid acceleration of discovery. One of the most important figures of the Renaissance was Leonardo of Pisa, better known as Fibonacci. In his book Liber Abaci, published in 1202, he introduced the Hindu-Arabic numeral system to Europe. This system, which uses the digits 0 to 9 and place value, was much more efficient than the Roman numerals that were still in use at the time. Fibonacci is also famous for the Fibonacci sequence, in which each number is the sum of the two preceding ones, 1, 1, 2, 3, 5, 8, 13, and so on. This sequence has surprising connections to many areas of mathematics and even appears in nature, in the arrangement of petals on a flower or the spirals of a seashell. The Renaissance saw a renewed interest in geometry, thanks in part to the rediscovery of Euclid's Elements. Artists like Leonardo da Vinci and Albrecht Dürer used geometry to create realistic perspective in their paintings. Mapmakers used geometry to create more accurate maps of the world. The Renaissance was a time of great intellectual ferment, and mathematics was at the heart of it. The stage was set for a revolution in scientific thought. Section 5. A new language: Newton, Leibniz, and calculus. In the 17th century, two towering figures emerged who would forever change the landscape of mathematics: Isaac Newton and Gottfried Wilhelm Leibniz. Independently of each other, they developed calculus, a powerful new tool for describing motion and change. Calculus allows us to analyze how things change over time or in relation to each other. It has become an indispensable tool in physics, engineering, economics, and many other fields. Imagine trying to understand the motion of the planets without calculus, or design a skyscraper without being able to calculate the stresses and strains on its beams. Newton's work on calculus was part of his larger project of developing a mathematical framework for understanding the universe. His book, Philosophiae Naturalis Principia Mathematica, published in 1687, laid out his laws of motion and universal gravitation. These laws formed the foundation of classical physics and explained everything from the tides to the orbits of comets. Leibniz, meanwhile, developed a more systematic notation for calculus, which is still widely used today. He also made significant contributions to other areas of mathematics, including logic, probability, and computing. The development of calculus was a major turning point in the history of mathematics. It provided a new way of thinking about the world and opened up vast new areas of inquiry.